Okay, so let's look at these problems, quadrilaterals in the coordinate plane. First up, on parallelogram PQRS below, if P is located at -1, 6 and S is located at -7, 3, so let's write those in, -1, 6, and S is at -7, -3, what is the slope of QR? So what we have to notice here is that PS and QR are parallel to each other. So if we were to find the slope of PS, it would have to be the same slope as QR. So let's find the slope for PS. So we'll do PS, and we'll do M equals change in Y over change in X. The change in the Y coordinate going from -3 to 6 is going up by 9. The change in the X coordinate is going up by 6. And if we divide by 3 on the top and the bottom, then we'll get 3 over 2 for the slope. And as I mentioned, the slope for QR would be the same value because they're parallel. On rhombus WXYZ, if W is located at -5, -2, and Y is located at 3, -2, what is the slope of XZ? So similar thing here, we start with finding the slope of WY. So the slope is change in Y over change in X, and the change in the Y value is 0, and the change in the X value is going up by 8, so the slope we get is 0. And then what we have to do now is, these are not parallel lines, these two, they are perpendicular. And when we have lines that are perpendicular, by the way, the reason why they're perpendicular is because we have a rhombus, and one of the rules for a rhombus is that the diagonals must be perpendicular, right? So that's something we have to memorize in the rules, okay? So anyway, once we know these are perpendicular lines, we know that means the slopes will be negative reciprocals, right? And it's a little bit tricky with this because the number is 0, but if we flip and negate this, we would get basically -8 over 0, right? And that is what we refer to as undefined, right? So the answer is undefined for the slope of XZ. On parallelogram STUV above or below, if S is located at -4, 1, -4, 1, and T is located at 5, 3, what is the length of VU? So remember, when they ask for the length, they're asking really for us to use the distance formula. And what we have to realize is that the distance between V and U is the same as the distance between S and T, because opposite sides are congruent for a parallelogram. So really, all we need to do is use the distance formula, and I'm going to use the shortcut formula, which resembles Pythagorean theorem, and we're going to plug in to find the change in X, change in Y. So the change in the X coordinate is it's going up by 9. The change in the Y coordinate from 1 to 3 is going up by 2. So we get 81 and 4, which is 85. That's d squared. So don't forget to square root both sides. We get radical 85. All right, on rectangle DEFG below, if D is located at -1, -1, okay, and F is located at 4, -8, what is the length of GE? So what we have to realize here is that since this is a rectangle, right, we know the diagonals must be equal in length, right? So to find the length of GE, I could simply find the length of DF. And finding the length of DF is just the same thing as finding the distance between those 2 points. So once again, we'll be using distance formula. And we'll start with the change in the X coordinate. Going from -1 to 4 means we're going up by 5. The change in the Y coordinate is that we're going down by 7. So here we get 25 and 49, right? Add those together, we get 74. That's d squared. And then we square root both sides, leaving d equals radical 74. Okay, so now you could try the right-hand column.